An LLM produces one token at a time, where a token is part of the word or the whole word. To produce the next token, the model looks at every previous token that came before it. This looking back technique is called attention. For each previous token, the LLM builds two vectors called key and value. Those vectors contribute directly to the model understanding of how this token actually correlates with whatever the model is trying to generate next. The problem is that this looking back process has to repeat for every single new token. Say the LLM is generating "those fries look bossy." Once it has produced those fries, it has to compute key and value vectors for both of those tokens before it can pick look. For the bussing, it has to do the same thing, but now it needs to do the same calculation for 3 tokens. Constant time to compute all of those vectors grows fast with the size of your input, which usually includes all your previous messages on top of the new ones. Once you compute the key and value for a token, those values never change. The next token gets its own pair, and the old ones are frozen forever. So researchers had a very clever idea of storing those vectors in the memory instead of reusing them. The stored memory is actually called KV cache. For every processed token, the cache holds its value and key at every layer of the network for the entire conversation. When the model generates the next token, it builds new key and one new value vector, appends them to the cache, and reads everything else straight from the memory, instead of deriving or recalculating it from scratch. With this simple trick, the speedup is actually around 10 to 100 times in token generation. The main reason your chat with Claude feels instant is because KV cache quietly handling the previous calculation on its side. The problem is that the cache is not actually free. It lives in the GPU memory, and it grows with every new token you generate. A conversation with 100,000 tokens of history needs tens of gigabytes of memory just to remember itself. For most frontier setups, the cache now consumes more memory than the model weighs itself. And this problem actually affects you as a consumer as well, as this memory requirement directly correlates to the price you have to pay for your tokens. The good news is that this problem is being tackled very actively right now. We got various optimization techniques now, like paged attention, prefix caching, and continuous batching that allows you to consume more tokens with the same latency and lower price. You actually do not see the cache directly from your API, but you feel it constantly. Streaming responses start fast because the cache is hot. The first token of a long prompt takes longer than the rest because the cache is being built from a phase called prefill before the generation can actually start. Anthropic and others provide you with context caching feature that can cut your bill up to 90% because they let you reuse a pre-filled cache across the requests. Every million token context window headline is really an engineering claim about somebody claiming that they have figured out how to manage the memory bloat more efficiently. If you want to get some hands-on experience working with those concepts, you can try preparato.com/labs. We have a bunch of hands-on labs that run on real GPUs where you can try to fine-tune the model, deploy it with vLLM, check the KV cache yourself, and do a bunch of different things like build a React agent, start an MCP server. Go check that out and subscribe for more. Thank you.